Hi guys, this recording is on theoretical probability versus experimental probability. So the first thing we're going to do is take a look at what theoretical probability is. And that is what should happen in an experiment. For example, if you toss a coin 100 times, then you would expect to get 50% heads because you would expect to get heads half of the time. Experimental probability is what actually happens after an experiment of many trials. So we're going to look at rock, paper, scissors, which is a game that I'm assuming most of you have played. So first we're going to look at the theoretical probability part. And so we're going to complete the table to show who would win under different combinations. So if both players pick rock, then it's a tie. If player A picks paper and player B picks rock, well, paper covers rock, so A wins. If player A picks scissors and player B picks rock, then player B wins because rock crushes scissors. Then we do that for each row. So if player A picks rock and player B picks paper, B wins because paper covers rock. If they both pick paper, it's a tie. If B picks paper and A picks scissors, then A wins because scissors cuts paper. And then finally, if A picks rock and B picks scissors, then A wins. If B picks scissors and A picks paper, then B wins. And if they both pick scissors, then it's a tie. So if we look here, we have 9 possible outcomes. So if we look at the probability of player A winning, there are 3 occurrences there. So that's 3 out of 9, which simplifies into 1/3. Player B winning is also 3 out of 9, so that's 1/3. And the probability of a tie is also 3 out of 9, which is 1/3. And so if you look here at all the possible winnings, all of the probabilities of those occurring add up to 1 because 1/3 plus 1/3 plus 1/3 is 1. When we look at the experimental probability, I played rock, paper, scissors with a partner 25 times. And these were our recordings. So I would be happy to tell you that I was player A, which makes me feel better. I won 9 times, player B won 7 times, and we tied 9 times. So we did this 25 times, so our experimental probability was for partner A, 9 out of 25. That was 36%. Partner B won 7 out of 25 times, which was 28%. And we tied 9 out of 25 times, which was 36%. If we look at the percentage for our theoretical probability, they would have all been 33.3%. So do our theoretical results match our experimental results? Not exactly. The A's were higher than expected, the B's were lower than expected, and the ties were higher than expected. And how could the experimental results get closer to the theoretical results? The more trials that you perform and the more results you gather, the closer you will get to your theoretical results typically. So some other examples. First thing here, we're going to look at frequency tables. This chart here is a frequency table. It records how many times things happen. That's what the frequency means. So like we're talking about rolling a standard die 50 times. So it's saying that we rolled a number 1 4 times. So the theoretical probability of rolling a 4 is 1 out of 6. Remember, that's what should happen in theory. So you just look at how many possible outcomes you have, which is 6. How many of them are the desired or favorable outcome, which is 1. So 1 out of 6 is our theoretical probability. When we look here for the experimental probability, we find the number 4. We see that it occurred 5 times, and this is out of 50 total times. So 5 over 50 simplifies into 1 over 10, which is lower than expected. Then we have a spinner here. So the results of spinning this spinner 75 times are shown here on our frequency chart. The theoretical probability of spinning a shaded letter, so I go here and count, and there's 6 out of 8, which simplifies into 3 over 4. What is the experimental probability of spinning a shaded letter? So A, B, and C were all shaded, and then E, F, and G. And so when I add all this together, I get 60 out of the 75 times that we spun the spinner, which is 4 over 5. So it's actually pretty close, but it is higher than expected because if you look at percentage-wise, 3 out of 4 would be 75% and 4 out of 5 would be 80%. So we actually use these things to predict what could possibly happen. So if we use on number 11A, they're talking about that we're flipping a coin. And so theoretically, how many heads would you expect to occur in 300 tosses? So what you're going to do here is this first part of our proportion is my theoretical probability. Heads is my desired outcome over my total possible outcome, so it's 1 over 2. And then you set that equal to your second part of your proportion here, which is x, because you don't know how many times it will occur, over a total number of 300 outcomes. Remember, to solve proportions, we cross multiply. So 2 times x is 2x. 1 times 300 is 300. Then we would divide both sides by 2. So x is 150. So theoretically, if we tossed a coin 300 times, we would expect 150 of them to be heads. Now, based on our frequency table and our experiment of tossing a coin 100 times, so if we're using our experimental probability, we use our actual frequency over the number of times we did this, so 58 over 100. And again, we set that equal to x over 300. You can simplify this first ratio if you want to, but it doesn't matter. You don't have to. When we cross multiply here, we get 100x equals 17,400. So x is 174 times. Number 12, A and B, is the same thing, but this time we're looking at the results of randomly selecting a letter in the word rhombus 80 times. So we want to know how many vowels we would expect. Well, there's 2 vowels out of 7 letters, so our theoretical probability of drawing a vowel is 2 over 7. Then we set that equal to x over 500 because we want to know how many times we should expect it, or we want to predict what would happen in 500 pulls. So we cross multiply and we get 7x equals 1,000, which is 142 and 86 hundredths, which is approximately 143. So if we pulled letters 500 times, we would expect to pull vowels 143 times. If we look at our actual experiment for choosing vowels, O and U are both vowels. So added those together and got 24 out of 80 pulls. And then set that ratio equal to x over 500. Cross multiply, 80x equals 12,000. So x is 150. So experimentally, we're a little higher with 150, and theoretically we had 143. So that's it for theoretical versus experimental probability. Make sure that you guys are working on your practice. Let me know if you have any questions. Bye.